Hello, I'm Corey Hines, Systems Engineer for Arista Networks. Welcome to the Emerging Tech Summit 2016 with Deltaware Data. I'm going to talk today about Arista products and our Extensible Operating System, or EOS, as well as CloudVision, our turnkey automation system for network configuration management and orchestration. Quickly on the agenda, I'll go over the corporate overview, a little bit of the product overview for hardware, talk a bit about Extensible Operating System, our programmable state-based Extensible Operating System. We'll introduce CloudVision, the turnkey automation integration, talk a little bit about our CloudVision portal, or CVP as I may refer to it, and then I'll do a short CloudVision portal zero-touch provisioning demo. It's already recorded, so I can't mess it up. But because of the network capabilities and things like that, I can't do a live demo. But come see me at the booth. I might try to do some live demos there afterwards. We'll talk about CloudVision portal change management and also our state streaming and workstream analytics capabilities that we're adding to CloudVision portal. So a little bit of company history. Arista Networks was founded in 2004 by Andy Bechtolsheim and Ken Duda. Andy Bechtolsheim was also the founder of Sun Microsystems and Granite Systems. Granite Systems was later bought by Cisco. Ken Duda was the first employee at Granite Systems. He's our founder, CTO, SVP of software engineering, and the original contributor to Extensible Operating System, EOS. Jayshree Ullal is our president and CEO since 2008. She comes from a long-time background, 15 years at Cisco Networks, working with the data center business unit, and grew that business to a multi-billion-dollar market. Arista Networks is a public company as of 2014. We are now 1,600 plus employees. 50% of those employees work in research and development, typically in software development. We have over 4,000 customers, give or take $5 billion market capitalization, and over 7 million switch ports shipped. When you look at the Gartner Data Center Magic Quadrant for 2016, you'll see that there's two vendors in the upper right quadrant, Arista Networks, as well as Cisco. Over the last 3 years, we've moved from the bottom right up into the top right, and we're the second largest market share network company for data center switching. So the market share data looks like this. We're currently running in these numbers around 12%. The new numbers are coming out soon that will show us just about to break 15%. So we went from 6 to 9 to 12, and now heading towards 15% as we approach $1 billion in revenue. For how big of a company we've become, we're still less known because we spend most of our money on research and development and invest in our customer needs, and a little bit less on marketing. Our hardware product portfolio in quadrants looks like this. We sell big modular switches, and we sell small top-of-rack type switches as well, right? And then we have a couple different variants, shallow buffer commodity type switching hardware on the left, and deep buffer value hardware on the right. For deep buffers, we typically work in big data environments, large-scale IP storage environments, and things like that. And then in the volume side of the house, leaf switches, high volume, Broadcom Trident 2 based typically. Currently, Broadcom Tomahawk. We'll talk a little bit more about these chips and what they mean. And then we run a single binary image across all of our platforms. So it doesn't matter if you have a 1RU, 1 gigabit product that we sell, or a 432 port, 100 gigabit system. It runs one single binary. That means we have one code base. All of our software engineers are working on that code base. We have a single binary image across all platforms. So you download it once, you review the release notes once, you do your bug scrubs, and then you apply it to your environment. When we fix a bug, it's fixed. Since we don't have different business units building different versions of code for different hardware, we have a very low regression bug rate and very high quality. The EOS operating system in a simple diagram looks a little bit like this. It's built off from a unmodified Linux kernel On top of that sits our hardware abstraction layer that allows us to port the code to any switch chip we like very quickly. So we're often first to market when new chips come out from Broadcom or Intel, and there's some other chip manufacturers out there like Cavium and others that we work with to develop hardware, and then we do or don't bring those to market based on market needs and the ability to productize those. On top of our unmodified Linux kernel and our hardware abstraction layer sits our sysdb. This is the core database for all state for the system, and this is a really powerful concept within an extensible operating system. It's a publish, subscribe, notify type database. It's an in-memory database, and it's not built on typical database technologies. And for the sake of brevity, I'll leave it at that for this particular talk. It's also our inter-process communication methodology, right? So traditional network operating systems are built on legacy approaches to inter-process communication and message bus systems that typically get congested and can get behind. So the slowest process ends up slowing down the entire operation of the switch, which then slows down the network when there's any kind of churn. So any kind of reconvergence or anything like that, we perform very well. And we have an ability to coalesce updates and catch up with the rest of the system very quickly. We also build it with APIs, wide open, extensible APIs. It's built from the ground up, not bolted on. Our CLI is actually running against our API underneath, which gives us the ability to make sure that the API is stable. We're eating our own dog food, so to speak, and we're using those APIs like our customers would. These APIs are open to our customers. They're open to third parties, our partners, and the ability to extend the operating system has been something that has won us major share within web scale environments, as well as high frequency trading, and now more and more in the enterprise. Now I'm going to shift gears a little bit and talk about Cloud Vision. So Cloud Vision is something that we're building on top of our extensible operating system to give us the ability to integrate with software-defined network controllers like NSX-V, integrate with OpenStack from an API perspective and the ML2 layer drivers, as well as some of the layer 3 capabilities within OpenStack. Gives us the ability to aggregate the network state with NetDB. So if you think of each switch element having a sysdb with all network state, we can aggregate that up and get a full view of all state of the network, including all topology information, all MAC addresses, all of the ARP information and things like that. And as we do that, we can abstract away the details of the physical network from controllers like NSX or Nuage or orchestration systems like OpenStack. So the controller doesn't need to understand that you're running a multi-chassis link aggregation system, doesn't need to understand the underlying physical aspects of the hardware, the chip. Certain aspects of the operating system are abstracted away. It also gives us the ability to do real-time data collection and historic trending. And so when I talk about Arista state streaming and real-time telemetry, we'll get a little bit more clear about what that means. Any questions so far? Okay. So Arista Cloud Vision Portal is a modern HTML5 web application for configuration management and automation. It's built on a CentOS Linux distribution. We distribute it as an OVA virtual appliance that you can run typically in a vSphere environment, but also in KVM. And it's built on Apache Hadoop with an H-based database, Hazelcast in-memory database, Zookeeper for cluster operations, and again, the modern HTML5 extensible front end. This gives us a modern distributed database capability for holding a lot of network state information and managing lots of devices. Cloud Vision Portal automation looks a bit like this. So this is the 9-tile view of the Cloud Vision Portal application when you log in. What we're doing here is giving the users the ability to have a central automation for multi-switch provisioning and validation and compliance checking It's a distributed database, as I mentioned earlier. It gives us the ability to manage switches and the network lifecycle from provisioning to end of life through a single pane of management. And we're doing network snapshots and things during change so that we have the ability to quickly roll back our network changes if something goes wrong, and doing that at a network-wide level rather than switch by switch. So this diagram here, this view here, is showing us the main network provisioning view for Cloud Vision Portal. And what we're doing here is building a hierarchical view of containers with devices inside of those. And containers can contain other containers. Hierarchical, similar to a directory structure maybe, and gives us the ability to then break up the configuration of a switch. So if you know switch configuration, like your running configuration or your startup configuration, we take that configuration and we break it up into what we call configlets. So we keep the traditional command line interface paradigm, but break that configuration up so that we can generalize it and apply very general configuration that's on 80 or 90% of your devices up at the top of the hierarchy, so that those settings will be inherited by the switches that are contained by those. We also have a label system so that you can assign an arbitrary label to these devices, and you can manage those devices with a label as well. This gives us powerful capabilities to manage configuration and to apply it one time and then have it inherited by all of it. So an example of that would be your AAA settings. Your AAA settings might be the same for your entire environment, or at least a single data center. Why would you want to write those AAA settings more than once? You might get it wrong, human error, you fail a compliance check, a compliance audit because of missing those configuration settings. So all we're doing is breaking up the configuration, generalizing it, and then having it inherited by these devices as you apply it. And we'll go through that a little bit in a quick video demo that I've made. So any clarification I can do so far on how that works? This will become more clear as we take a look at this quick video. So this is, let me go ahead and maximize this. So this is the Cloud Vision Portal application. I'm logging in here. I'm going to go to my network provisioning view here. And what I'm doing is I'm actually waiting for devices that are in what we call zero-touch provisioning mode to check in with Cloud Vision Portal. So any Arista switch that you purchase, you can pull it out of the box, rack it, connect the management interfaces, the power cords, the data plane interfaces, and any switch that does not have a startup configuration on it will boot into what's called zero-touch provisioning mode. What that means is that it's going to fire off DHCP requests out all connected interfaces, including the management interface. If it receives a response back, IP address, default gateway, DNS information, as well as an option 67 boot file, it will then go download that boot file. And it will run that boot file. Typically that's a script, and in this case it's going to be a script called Bootstrap from CVP, which has it check in to the CVP server so that it can be managed. So again, much like a Pixie boot system, this is similar to that, not quite the same thing, but a lot of the same concepts. DHCP, give me a file, boot up, check into the GUI interface, and then I can pick it up from there. So this particular switch, which I'm actually running in a virtual instance, VEOS, these two switches are probing right now for their DHCP. We've got a DHCP success response. We're picking up an IP address. We're checking in with the CVP server, Cloud Vision Portal server. In just a moment, I'll switch there, refresh this, and you'll see that I've picked up that device. And then what I'm going to do is I'm going to move that device to a container called CB demo. I'm going to show a few things there with our configlets and what we call configlet builders. So when I click OK, it's going to say hierarchical containers assigned with Configlet Builder. Do you want to generate the configlet via the builder? The answer is yes. And then we're going to quickly fill out a form with the host name. We'll call this switch foo.lan. We're going to put an IP address on it for the management interface. We'll give it a subnet mask length of 24, pop in a default gateway, and click generate. On the back end of this builder is just a little Python script. It's about 15 lines of Python that basically just takes those inputs, pops them out of variables, and puts them into the proper configuration syntax that you would see on the command line. This is just an example. There's some other capabilities that we're working with Infoblox, for example, and some other vendors to actually reach into an IPAM system where you probably have already entered this information and then pull that out automatically. So you don't have to have forms. You can just have API calls to Infoblox, pull that information out, assign it to the device, and hunky-dory. So we click Generate there, and it's going to create a little bit of config. It's going to look very familiar if you're used to any switch operating systems. I'm also going to build some VLANs, and I'm going to assign those to a VXLAN network identifier. I'm going to create the base IP address, which is going to create the SVIs for these VLANs, the switch virtual interfaces. And then I'm going to go ahead and do a validation of this configuration before I move on. So I'm creating VXLAN configuration through this by entering just a few pieces of information and using a little bit of automation on the back end to create those different SVIs. So we'll do a quick validation here. This is mostly just to show some of the different elements that we're inheriting. So we're inheriting AAA settings. We have to turn on our eAPI, that's our extensible API to manage the switches. And then we look and we can do a comparison. We can see that the running configuration right now is in zero-touch provisioning mode, so all the logging is turned up. You see that on the right side in red. And on the left side is our design configuration. This is what we're going to push to the switch, okay? So this is part of the zero-touch provisioning process, and I'm just showing kind of what changes are going to be made to the switch as we go through. So we'll scroll down, we'll investigate these changes, and then we'll go ahead and click Save. But as you can see, we're inheriting a lot of information, including an XMPP Jabber protocol setup, name servers, various different settings that we didn't manually enter. This is all through the inheritance and reuse of existing configuration code. So once I click Save, it creates a task. So Cloud Vision Portal is not going to go and change your network. It's going to create tasks that can be run now by a user, that can be run later, or they can be scheduled in a change management task, so that you could have multiple tasks running in order with checks and snapshots in between, so that you can verify that these changes are doing what you expect them to do, and you can have verification scripts running within those. And one of those verification scripts could be as simple as ping an IP address, or it could be as complex as use curl to go make a transaction against an application that is then tied to a database backend or something like that. So you can do a little bit of verification or application verification for your applications teams, and hopefully reduce the amount of finger pointing you get based on certain changes. So everybody has a really sensitive application in their environment. If you can write the test yourself, you can do some verification and show your partners, hey, it wasn't my change that caused this problem, right? It must have been an overlapping one from somebody else. Let's see if we can figure that out together. So we're just going to go ahead and run this task. The other thing that we can do is apply image bundles to containers, which means when we first provision this switch, we can make sure that it's running the exact code version that we want, that we should be running, that's consistent with our company standard. So a switch might ship with a newer version than what you're running in production, or an older version. And how many times have you had to do a change management ticket on a device right after putting it in production because you didn't have something set right, a version of code or a configuration setting? So these are the things that we're trying to avoid with this. So you can see that we get a message there that the VEOS lab 417.1F SWI differs from previous boot image. That's showing us that we are running a previous version, and we're actually going to copy that to the hidden file on flash and then boot from it. I'm going to move this ahead a little bit. Okay, so the switch reboots after updating the code. It checks back in with CVP. CVP realizes that it's not done, and it's going to actually push that configuration that we looked at just a moment ago. We have a full log of what's going on. So this is basically the API and what it's pushing to the device. That looks like a mess, but you can actually, as you get used to it, look through it and understand what it's been pushing. This device is going to go ahead and reboot again. It now has its configuration. That means it will not boot back into zero-touch provisioning mode. And when it comes back up, we'll see that it has a host name, and that's a good indication that our push was successful. And then we'll do a couple of checks to make sure of that. And then I'll show some compliance checking capabilities that we have in a moment to help us understand what's going on in the environment from the perspective of maybe a rogue change or something like that. So this is almost done. I apologize for how long this takes. If I was doing a live demo, it would take even longer because I edited that one a little bit to reduce some of the boot time. But bear with me here. So we're just waiting for the device reboot to finish and for everything to update. So we see that's completed. We're going to go ahead and take a look at the configuration here again. And we're going to see that we have AAA settings that we've inherited. We have something called event handlers. We have one of those that we've inherited. I won't explain exactly what it does right now. And then something I call switch defaults. And this basically is just things like we ship our switches to run multiple spanning tree, MST. Many environments, especially if you're in a Cisco environment, you want to interoperate. A lot of them are running rapid PVST. So in the switch defaults configlet, I just changed that to rapid PVST. And that way, any switch I deploy in this environment will definitely be running the right spanning tree type for that environment. We get a few other things. And then I'm going to go ahead and log into this switch, make sure it's reachable, and show that it is. And then we're going to do some things where we make a change manually on the command line and see how that affects CVP from a compliance point of view. So the idea, if you're running CloudVision Portal or CVP, you would use that as your single source of truth for what the configuration should look like. And here I'm just outlining a few of the things that we've inherited that we didn't type manually or have to worry about as we deploy this switch. We see our VLANs, our VNIs, and our switch virtual interfaces are created. We have our VXLAN and VLAN mappings. Default route, we turn on IP routing. We sell layer 2, layer 3 line rate devices. We run BGP, OSPF, and ISIS as routing protocols. We do everything standards based, no proprietary protocols. And then I go ahead and I do it again, and I'm not going to show that. So just a moment as I catch up here. Just do some showing of some of the configurates that are applied. So you can see this is command line information that you're probably used to as you're working with your other vendors in your environments. We're trying not to reinvent the entire paradigm. We're not trying to take the command line away from our users, but we're trying to give them a better way of managing and automating their environments. Okay. Do a quick verification on the configuration. And okay, we're going to go ahead and log into the second switch. We're going to make a change on the command line, something simple. Turn off IP routing. Probably a bad thing to do in production, especially if it's running OSPF, BGP, or ISIS. We'll run a compliance check on the container. So it'll check all devices. We see that we are now not compliant. It turns yellow or gold. And we can see that the change that the difference between the two devices is that we turned IP routing off. We can see that very clearly in red. So that was essentially a change that was not, well, it might have been authorized, but it was not done in the proper way, right? We should have pushed that out through CVP. And so what we're going to do is we just validated the config, and we're going to push the IP routing statement right back on and get this thing back in compliance and hopefully back in service before the phones start ringing. In this particular case, the phones are probably ringing. That's why we do this in labs. So very quickly, we have that turned back on. And that's really the power of this tool, is giving you the ability to quickly identify the changes and roll those back. And then when we check our compliance, we'll see that everything's in compliance again. So that's a quick demo. Getting back to the presentation, that's just the provisioning features of CloudVision Portal. But what you can see is we unboxed a switch, we racked it, we put 2 power cables in it, we plugged in the management interface, we plugged in the data plane interfaces, And what we were able to do with just putting in a few lines of information into a form is we upgraded the EOS to company certified image. We deployed the company standard AAA NTP domain name settings. We configured an email client on the switch, also integrated it with XMPP Jabber for multi-switch command line interface. We have a local config versioning event handler. Every time the startup config is changed, it will take a backup. We configured the management interface, default route, et cetera. We enabled IP routing, set the time zone. We changed it to rapid PVST from MST, and we performed configuration validation before we pushed all this to the device. Some of the features that we're working on right now that will be GA towards the end of this year are our change management capabilities. So this is really taking it to the next level and trying to understand how do we make changes to a network at a network-wide level in an automated, orchestrated way where we can understand that the changes that we've made had the desired effect and we can roll them back quickly if we have any problems. Because everybody here knows that all of our changes are 100% solid and we never have any problems, right? I might have worked with some of the people in the room on some changes that didn't go so well. So the idea here is that network uptime is critical. If the network isn't working, nothing's working. We can affect many, many applications, so that's critical. We can perform graceful change controls. We can automatically create snapshots pre and post change for comparison and scripted testing. This is useful for something we call smart system upgrade. We integrate with workflow tools like ServiceNow. So again, if you create a task in CVP and you're integrated with ServiceNow, you can have some change controls applied to that where the task cannot be run unless the workflow has gone through the proper change advisory board approvals and things like that. Gives us full audit trail and compliance. This is something I talk to customers about sometimes, and I show them we have this configlet. We have all the revisions of that configlet going back to from the time that it's been created. And I ask them, does this help you with your compliance requirements? And unanimously, they say yes. If I can reduce your compliance friction and headaches, I can reduce your cost, right? So I worked a little bit in compliance. I always tried when I was on the enterprise side of things to get out of that role because it's hard and nobody wants to do it, right? But it's really important, right? If you don't comply, there's financial impacts to that. If you're not in compliance, you're also probably not as secure as you should be. So these things are very important. And proving that you're in compliance is very important. And it also, if you can prove it quickly, allows you to get back to the strategic things that you should be doing. So, of course, network uptime is critical. Some changes don't go as planned, right? This gives us the ability to roll back the entire network to a previous state. That includes network operating system versions, images. It includes the configuration. So this allows us to do that quickly without the manual hands-on requirements for doing that. The traditional way would log on the switch, go downgrade that one. Log on to the other switch, go downgrade that one. Get it back to the versions that we were on before the change. Pull out all the changes. Well, what were the changes? Do I have a good run book that shows me that, right? So this is a way of replacing that. So that's our change management capabilities. So I'm running through these a little bit quickly because this is usually an hour talk that I do. So make sure to let me know where the clarification is needed. So I'm kind of really trying to pack a lot of things about Arista into a very short talk. But what I really want to do is just inspire you to come talk to us at our table. Talk to us about what you're doing in your environments from a network perspective and maybe some of the pain points that you've been experiencing that we can help with. And let us know if Cloud Vision Portal is something that you think might help there. So then we get into streaming telemetry. So this is something where I think telemetry has become a bit of a buzzword lately. A lot of different areas, not just networking, are working on telemetry capabilities. And one of the problems we've had in networking with regard to visibility and telemetry is we've had a very kind of legacy approach to things, what we call like 1990s networking versus what we're building data center architectures, we're building 100% uptime environments, critical applications that people are using for e-commerce 24 hours a day in many different time zones. We have traditionally been using a polling approach with SNMP where we get very course level data and we make some pretty big decisions on that data. But what we don't see in that data is the granular information, like microburst information, or really granular data about the environmentals of the switch or switches in your environment. And typically what people do is they will cut down their polling times down to 5 minutes or less, and then drive up the CPU utilization on their networking infrastructure, and sooner or later you get into conflict with what you're trying to do, which is forward packets, with what else you're trying to do is understand how well am I forwarding packets. So the state scope is limited to the SNMP MIB definition. If you've ever worked with MIBs, it's not a very fun thing to do. Per switch per device versus a network-wide scope. And you just don't get dynamic event correlation. And typically correlation has been very difficult to achieve. So what Arista is doing in streaming telemetry and analytics is we've built a state streaming infrastructure. We have our CloudVision analytics engine that's crunching the data and creating events according to that data. And we have the CloudVision telemetry apps to display that information. So what is state streaming? So I started off this talk talking a little bit about EOS and SysDB. Inside each switch is a SysDB. We aggregate that up to what we call NetDB. And what's inside that database is all of these things you see here: interface counters, latency analyzer data, that's buffer utilization at a microsecond scale, SFlow data, our power draw, our fan speeds, VXLAN mappings, our MAC tables, ARPs, IP routing tables, etc. It's everything that you could possibly want from the device, and we can stream it off in real time. And we stream it to CloudVision Portal. So our foundation for that, I mentioned SysDB. We aggregate that up to something we call NetDB. And then we're also working with the community around OpenConfig. Has anyone heard of OpenConfig? OpenConfig is an emerging consortium, potential standard, for Yang-based models for networking devices to replace SNMP. So we're doing some things right now with state streaming, but we're also embracing the community approach. And you'll find that we do a lot of things in very open ways, whether it be OpenConfig, open APIs, and such, so that we don't lock our customers into one way of getting at this data or doing these types of applications. There's three components to the CloudVision backend infrastructure. We have a state repository, the analytics engine, and an API server. And here's why that's important. For state streaming, from left to right, we have all of our switch devices streaming into one or more backends. The state repository could be the CloudVision state repository. It could be a third-party partner storage infrastructure, or it could be something customer-specific. So if you already have tools like Kafka, Kibana, Elk, things like that in your environment, that's going to work very well with this. And we even have demos where instead of using CloudVision streaming analytics viewer, we're actually using Kibana and Elk to display the same information. So if that's something that you already have, and a lot of our web scale customers do, you can stream that today right in there and start getting analytics and display it yourself. If you want to take advantage of our analytics and the events that we're able to correlate, then you can just stream it into CloudVision. And this is what it looks like. So the CloudVision telemetry apps, so the workstream analytics viewer, we have horizon graphs, we have full fidelity information. We never lose any of the granularity of the data, but we can also pull that information up into a more general view so that you can view trends and things like that. You can click on any of these graphs and go into a real-time mode and see information streaming in real time. For example, fan speeds, if that's something that you're really interested in, you can watch the fan speeds change all day long by 1 or 2 RPMs. So, and why that's great to talk about here, and maybe not to look at all day, is it just shows the granularity. It shows that every time that fan changes speed, we're getting a data point on that, and we never lose the fidelity. We recommend that people put a terabyte of storage behind this to start. You just put more storage against it as it grows, and you can go back at least a year in all of these metrics. So if you want to know what your routing table looked like 6 months ago, you can do that. No other vendor's doing that today in networking, right? You know, people can tell you what the state of your network is right now. What does my routing table right now look like? Okay, I have routes to these destinations, but I have a problem. What did it look like 5 minutes ago before the problem started? That's powerful stuff. That's what we're doing with state streaming. So to summarize, we have triggered workflows, proactive monitoring. So we've been doing a lot of work in visibility for a long time, and we have some tap aggregation products And we have a lot of triggered workflows. So events happen, we use event handlers to pick those up, we run scripts, we can trigger all kinds of things. We can trigger a monitor session, or what people would typically call a span session. We can have those dynamically triggered. We work with Bro IDS, for example, in a lot of the universities, and they're doing work with large elephant flows that they are not interested in, and using API calls back to our devices to say, drop that, I don't want to see that, in real time, in an automated way. So it matches a certain criteria. This is an elephant flow I don't care about. Drop it so that I don't overwhelm the switch and lose the traffic I am actually trying to see. Workload visibility. So the ability to look at your workloads from the perspective of this telemetry data, or through real-time packet capture information, or through our integrations with NSX and vSphere, as well as OpenStack, to understand how the virtual resources are connecting to the physical infrastructure and restoring that visibility. And then the real-time streaming analytics I just mentioned. Yeah, this is my last slide, and this is really just looking at the big picture about EOS and state streaming and our tap aggregation capabilities. So I'm all done and ready for questions. Well, so this is on the visibility stuff, and I know you understand that. So the data's coming in through an Arista switch from tap aggregation. It's going off to Bro and being analyzed, and then Bro is looking at it. And if it matches a signature about data, about information or a flow that they don't care about, they'll signal back to drop that. So the intelligence is in Bro at that point. Mm-hmm. Nope. No, so we're not going to know anything about the flow, right? That's the analysis tool that's going to understand that. Yeah. So we're mechanically moving those interesting flows through the switch. Yeah. Yeah. There's a paper that UC Berkeley did that I'll get to you soon that will tell you how exactly they're doing it, but it's all through eAPI. Really, they're just calling back through eAPI to the switch to tell it what they're interested or not in that case. Mm-hmm. They can be across any platforms or any environment. Yep. Yep. Yeah, as long as you can tap it, and then you can communicate over APIs back to the device. Yeah. What's the data speed? All the way up to 100 gig. Yep. So we're doing 100 gig capabilities in switching, 100 gig capabilities in tap aggregation. I have local customers here running 100 gig tap aggregation right now.